Alright class, let's go ahead and do a quick math problem based on the topic 7.10 and 7.11. We just derived the um, equation for a steady flow device that has uh, working fluid incoming and working fluid outgoing, and that flow is steady. And we saw that what is the work produced by those type of device, or what is the work consumed by this type of device. So this problem, it's basically it's asking that liquid water enters at 60 kilowatt pump, right? So this pump can absorb, or rated power of this pump is 60 kilowatt, and the input pressure is 100 kilopascal, and the working fluid is coming at the rate of the incoming fluid, it's coming at the rate of m equals to 5 kg per second, right? And determine the highest pressure. So what is the highest pressure? P2, right? Highest pressure of the pump at the exit. Neglect the kinetic and potential energy change of the water, and take the specific volume to be 0.01 kg meter cube per kg, right? So let's solve this problem. So first of all, this is a steady flow device. That means why? It's because of its that pump is handling the liquid at 5 kg per second, right? It has the mass flow rate, and also this pump is a work consuming device, and it has the rated pump. So it's not a closed system, that's the thing, right? So for reversible and also for steady flow device, we just derived the formula, right? W equals to so since it has a mass flow, so we have to take this term as well, 1 to 2 v dp plus we saw that if it does have the kinetic energy change and potential energy change, then this is the formula. We just derived this formula. However, for our case, it says that assume that the kinetic energy, or neglect the kinetic energy and potential energy change of that water. So that means we are not going to use these two terms, right? So the W pump equals to 1 to 2 v dp, right? So that's the equation. So now it's a pump, and the volume is not changing, the volume is constant, right? So if we assume that this volume is constant, then the integration will become mass flow times the volume times P2 minus P1. So this is relatively simple expression now, the pump, right? So for this equation, we know that the P1, we know that the volume, specific volume of that water, and we know the mass flow, and we also know that the power input of, or the power of the pump. So the pump is power of the pump, rated power of the pump 16 kilowatt. So if we want to express it in work, kilowatt in in joule, then it will become, so right now it's in kilowatt, right? So the pump input is 16 kilowatt. So for the watt, we know that watt equals to joule per second, right? The power equals to work done by work done per second. So that's the relationship. So it will be kilowatt. So for the kilowatt, it will be kilojoule per second. So 16 kilojoule per second. And mass flow, for our case, it's given as 5 kg per second, right? 5 kg per second. And the specific volume, it's given right here. The specific volume of the water, 0.001 meter cube per kg, 0.001 meter cube per kg. And my apology for the noise. And and the pressure change, right? The pressure change P2 minus P1 in the it is 100 kilopascal, right? So that's the and we have all of those formula now. So if we solve this problem, then we'll get the P2, right? So actually P2 minus 100 equals to 16. So it will be 3200. Then P2 equals to, actually I made a mistake, it will be 16 by 5 by 0.01, 3200, sorry, it will be 3200. So 30 3200 plus 100 equals to 3300 kilo pascal. So that's the answer for this problem. The pressure or the exit pressure P2 equals to 3300 kPa, so which is here, right? 3300 kPa. So we saw that the if it is a pump and work consuming device, we just derive the formula and this we solve the problem. And basically we know how to utilize those formula and solve this problem. So I hope you guys can practice more and solve those type of problem. And also if I add like some sort of conditions that this is a isothermal condition, then which formula you should choose. If it is a polytropic process, or maybe if it is a isentropic process, which formula you should use. So that's all about this math problem, and we'll do more math problem in the following upcoming classes. But for today,